Who should we start with? Did we pick somebody to start every day with? I don't think we did. What number should I pick? 1 through 38. 38. 20. Milo, you get to start every day for at least the next couple weeks. Now that's good and bad. It's better than you're probably fearing. So the first person generally gets the easiest question, and you kind of get the choice to answer it or just choose somebody. So we basically just need a place to start every day rather than, whatever. Okay. Mila, do you remember why that picture up there does not have a two-sided limit at -1? I'll give you an iffy yes. If you wrote that as an answer on a test, it'd be wrong. But you're on the right track and maybe you mean it correct. Do you want some assistance from somebody? I don't know what a shrub means. Okay. Okay, choose somebody. A number 1 through 38. And I screwed up the numbering, so it's real hard to predict where your friends are. 9? 29. Charlie.
It's because the y value is different for both.
Perfect. Coming from the left-hand side, the height of the graph is -1. Coming from the right-hand side, the height of the graph is +1. Because the two sides don't converge on a single value, there's no limit. A limit means both sides have to turn into the same number. Basically, they have to point at each other. Okay, number 2 is actually the reason I wanted to make sure that, where'd my mouse go? Number 2 is the reason I actually wanted to put this up here. Because this is the one that always feels like it should have an answer. I want to emphasize that I used the word converge on a single value. Has anybody ever graphed sine of 1 over x? Do you ever remember doing this one in previous classes? No? Maybe I'll put up Desmos. Because I have, where is it? It's right here. Okay, I'm going to shut that one off. And sine of 1 over x. It comes out a million times better on Desmos than it would on a normal graphing calculator, because the normal graphing calculator has pixels, and when you keep zooming in on a graphing calculator, it still has the pixels, right? Like it's not going to get any better resolution. Well, what happens on a graphing calculator is when you zoom in on this graph, it's just one solid screen. You can't see anything. Because if I zoom in repeatedly, the closer I get, the closer and closer the lines are together. So no matter how much I zoom in, you can kind of tell that those lines are getting closer and closer and closer together. And so if I'm trying to find the answer at 0, on the left-hand side, I can see that line is not settling onto any number. The line on the left-hand side is going up and down quicker and quicker. It's not settling or converging to a value. So if I come from both sides on sine of 1 over x at 0, I can't tell what number it's turning into. And so there's no limit because of that. This is kind of a special case one because most graphs don't do that. The farther you zoom in, the worse it looks. Somebody's getting a lot of snaps. Okay, that's number 2. I don't know what you want to write in your notes. You can write whatever you would like. But the main reason is because they don't converge. And it's hard to see on the picture on the notes, just same as this. You couldn't tell until I zoomed in. Okay, and then the third one is sort of similar. I said it briefly yesterday, and I don't know if anybody remembers. Do you guys remember what I said about the arrowheads when we were trying to draw and find a limit from a graph? The arrowheads point at each other, and so that means both sides are turning into the same number. Okay? If I'm trying to find a limit at an asymptote, both sides are shooting straight up or down, whatever. And the infinity one can be tricky if you look at it on a calculator, because both sides would have the exact same answer. And so on a calculator, it almost looks like it's converging. But if you're looking at a picture, both sides are pointing up, because that's where it's kind of going. And so you won't be able to find a limit because both sides are not turning into a number. Now technically they are turning into infinity, but it's a technicality because infinity is not a number. And so this is a goofy gray area. In 4 sections, we're going to learn that this does have an answer, and the answer is infinity. But because we're just learning limits, we're going to say there is no answer because infinity is not a number. So it's a gray area. That technically is no limit though. You will not be marked wrong if you write no limit. When we get to it later on, I will tell you specifically how to write the answer on the AP test. Okay. I can probably stop there unless you would like me to go over a Desmos one, but that takes quite a bit of time to type in. So I would say we are probably better off stopping here. You should be able to do any question involving a graph in the homework, but the homework will not be due Sunday night. Unless you want me to split up the homework into graphs and tables separately, but I don't know, I'm fine just keeping it together and making it due like, I don't know, Monday night or something or whatever, I don't know. I guess we'll figure it out along the way, but I will change Schoology so that it's not the same. If you want to do any homework over the weekend, who should we call on? Wait, who got called on last?
Me.
Who's going?
The kid next to Drew.
I don't know who Drew is.
Drew's in the black hoodie.
Okay. Rowan. Rowan, what should you do this weekend? Except for 5 people in here. Good. Get ready to answer the unit circle so you can do the test quickly. And or if you're a busy person, well then try to manage your time and get some of the homework done ahead of time, whatever. Okay, Monday we'll finish up.